the first one that we're going to work on is moles to particles. So, moles to particles. Now, the thing is, remember, particles is a kind of a catch-all term. This could be atoms. Generally speaking, you're going to see atoms, you're going to see molecules. But any type of particle that we're dealing with that isn't a mass, that isn't a volume, that's what we're going to be dealing with. So I'm just going to put dot, dot, dot. And we'll kind of take the beginning of that with, we just don't know exactly which ones we're going to get. And a couple things you got to remember. One, you always got to start with the given. What are you given? Since we're dealing with particles, whenever you're dealing with particles, we're going to be dealing with Avogadro's constant. So, of all of them, this is the one that is going to be using Avogadro's constant when you're dealing with particles. So if it's moles to particles or particles to moles, this is the one that you're going to do. And even if we wanted to go crazy and go moles to particles, or not moles to particles, but mass to particles, you're going to have to go mass to moles, moles to particles. And then you use Avogadro's number, because anytime you need to get to or from particles, Avogadro's number is the way to go. And 3, use unit analysis. I'm going to say this is the best way to do it. And everything that I do is going to be unit analysis, even though I'm going to show you a couple, I don't want to say shortcuts, but I'm going to show you a couple different ways that you can go about doing it. Because once you know unit analysis, you never have to remember all the different ways to convert things. All you have to do with unit analysis is, here's what you need to know. The units you start with, the units you will end with, and conversion factors. That's all you're ever going to need with those. And the nice thing is, it's the whole give someone a fish, they'll, what is that? Give them for a fish, they'll be fed for a day. Teach them how to fish, they'll be fed for a lifetime, or something like that. That's what I kind of equate unit analysis to. Now, with unit analysis, let's go with an example. Well, it doesn't matter. We're going moles to particles. So example 1, we're just going to do the unit analysis of it. So we're going to go moles to number of atoms. Now, what are we given? Yeah, we're given moles. So that's our given. And that's what we need. So basically it's what you got and what you need. Now the unit analysis works like this. If we just kind of set this up like this. The given is always the first step right here. Now, what did we say we can do with units? We can cancel them out. We can treat units like variables in algebra. So if I have moles up here, do I want to end up with moles? No. so I'm going to put moles down here, and then up here is going to be number of atoms. And so this is my given. This is my conversion factor. And the nice thing is, moles divide out. And what are we left with? We're left with number of atoms. So, at that point, we're left with the number of atoms. Isn't that what we wanted? Yeah. So, this is unit analysis where you just analyze the units of the problem without any numbers. Because if you can do this, then the problem becomes a piece of cake. Because let's say, example 1a, how many atoms are in 3 moles of, who cares, sodium? So we got 3 moles of sodium. Now with unit analysis, I always draw the line a lot bigger than it ends up having to be, but that's just me. I know what's going to be given up here. What's given out of this equation? 3 moles of sodium. So this is the given part. So you always have to look for what's given. So we got 3 moles of sodium. Now, so this was given, and you don't have to write given underneath it every single time you do one of these problems, but that's okay. Now, we need the conversion factor, which is going to go here. But first off, unit analysis says, I don't want moles in my final answer, so I'm going to get rid of moles. So I'm going to put moles of sodium down here, and then number of atoms up here. Now, what's the conversion factor? Now, where does that go? Number of atoms. 1 mole, the conversion factor is 1 mole is equal to 6.022 times 10 to the 23rd atoms. Because atoms falls under that category of representative particles. So 1 mole, we put that down here, and up here we put the 6.022 times 10 to the 23rd. Now it's a math problem. The nice thing about this is, as you move across, what are we going to do to these two numbers? Multiply. As you move down, what do we do? Divide. So, hopefully this works. There's always a glare. I can't. I've tried. So, how many moles did we have?
3.
Alright, if you hit Control Divide, you create your first fraction. You get 3 over 1. Thanks. Times your second thing here, which would be 6.022 times 10 to the 23rd, all over 1. You hit Enter, and our answer would be 1. We'll go 2 decimal places, just for fun. 1.81 times 10 to the 24th atoms of sodium. Now, if you have just a plain old scientific calculator and you can't use the Inspire, that's fine. Just remember that there's a phantom 1 down there because these are all fractions. Yes, sir? 10 to the 24th power. Technically, this is what's going on here. For a scientific calculator, it'd be 3 times 6.02 times 10 to the 23rd. Then we divide by that 1, and then you divide by another 1. And I'd put the 2 dividing by 1s, even though we would never actually do that in a calculator because that's a futile exercise. If the numbers are different, we're going to have to divide by them. So if this was flipped and the 6.022 times 10 to the 23rd was in the bottom, we'd divide by that instead. So I want to make sure that you understand that we're going to go that times that, divided by that, divided by that. Yes, sir?
What do you do first? We should divide or multiply?
If you want to go this divided by this times this divided by this, your calculator does order of operations. So it'll actually do everything in order. I do all the multiplication first, and then I start doing the division afterwards. That's just how I've always done it. I always take care of the top, and then I start dividing by the stuff in the bottom. So that would be, I guess, my recommendation. Multiply, then divide.